history of refrigeration goes beyond the 18th century. In the year 1806, several tons of natural ice were brought from the snow-claden mountains and hills for storing perishable food such as meat and fruits in large quantities. The owner of the cargo was Frederick Tudor. He had almost lost his precious cargo, since in the plains no storage facilities were available for its preservation. The financial loss would have been much greater but for some quick thinking on the part of Frederick Tudor, who later destined to become known as the Ice King. He constructed ice houses by insulating them with pine sawdust to prevent the melting of the ice during its transportation. And Frederick Tudor turned his idea into an extremely profitable business, and that was the first large-scale commercial venture in refrigeration. He contracted for the cutting of ice in ponds and rivers throughout New England and shipped it across the world. The business which he founded changed the lives and habits of people throughout the world. Jacob Parkins was a pioneer in the development of refrigerators. In the year 1834, a British patent was registered in the name of Jacob Parkins for production of artificial ice. Initially, a hand-operated refrigeration system with condenser was developed. Later on, the development of high-speed electric motors and compressors paved the way for the modern domestic refrigerators. The manufacturing of refrigerators involves the production of a series of assemblies such as compressor, evaporator, condenser, cabinet, and the door panel. The principle of working of a domestic refrigerator can be explained with the help of a flow diagram. As the refrigerator is switched on, the compressor starts working and the vapor of the refrigerant gets compressed and heated, and the refrigerant vapors are pushed through the discharge pipe. The refrigerant vapors slowly reach the condenser. The condenser is a coil of metal tubing which is exposed to atmospheric air. The air surrounding the coils of the condenser absorbs the heat from the vapor, and the vapor condenses to a cool liquid refrigerant. The liquid refrigerant then passes through a filter dryer, and the liquid refrigerant is fed into a capillary tube. The capillary tube is a thin tube with very small cross-sectional area, and this constricts the flow of refrigerant passing through it. When the refrigerant fluid passes through the capillary tube, the fluid pressure drops and the refrigerant enters the evaporator at a low pressure and low temperature. The liquid refrigerant boils when it passes through the evaporator coils, taking the heat from the cabinet space where food items are stored. The liquid refrigerant at high temperature and at low pressure enters an accumulator. From the accumulator only, the vapors at low pressure enter the compressor for starting another refrigeration cycle. The compressor is the heart of the refrigerator, and it is totally enclosed and hermetically sealed when fitted in a refrigerator. One can trace the flow of the refrigerant vapor from the inlet to the outlet of the compressor. The condenser is a coil of metal tubing, normally of 6 to 8 millimeter in diameter and about 10 meters in length, fixed onto a plate mounted at the rear side of the refrigerator. It helps to dissipate the heat from the high pressure and high temperature refrigerant vapors, thus condensing the vapors to a liquid form. Filter is used at the end of the condenser to separate dust particles. Silica gel kept in the filter also ensures that moisture and water vapors are removed before the refrigerant enters evaporator coils. The capillary tube is a thin tube with very small cross-sectional area, and this constricts the flow of refrigerant passing through it. Evaporator coils are kept inside the freezer in the top portion of the cabinet. Maximum cooling occurs at the freezer compartment. Evaporator coils carry the volatile refrigerant fluid, and the heat inside the cabinet space makes the refrigerant fluid to boil, and in this process, heat is extracted from the space surrounding the evaporator coils. Accumulator is in fact a safety device which traps the liquid refrigerant and ensures that no liquid can go into the compressor and damage it. Accumulator ensures that only vapors are allowed into the compressor. Thermostat fitted inside the cabinet ensures that desired temperature, that is more cooling or less cooling as the case may be, is maintained in the cabinet space. Compressor, condenser, filter and capillary tube are mounted outside the cabinet. Evaporator coils and thermostat are housed inside the cabinet. Cabinet is made of 20 gauge low carbon steel sheet or galvanized sheet. These are decoratively spray painted to avoid chipping and corrosion and dried up in baking ovens. The cabinet is insulated by using resin, impregnated fiberglass or mineral glass wool, or sometimes polyurethane foam insulation. The main liner and inner door liner are made of plastic material such as high impact polystyrene. The liners are made by vacuum forming process. Cabinet and door panels are manufactured in vertical hydraulic process. The door is also fitted with polyurethane foam insulation. The cabinet and door panels are designed such that maximum volume for food storage is obtained with minimum floor space occupied by the refrigerator. For efficient operation and maintenance of refrigerators, certain simple guidelines are to be followed. Defrost the refrigerator at least once in a week by turning the thermostat knob to defrosting position and keep the fridge on till the ice accumulated on the evaporated coils gets completely melted. This ensures better cooling of the cabinet space and higher efficiency. Defrost the refrigerator at least once in a week. Use a voltage stabilizer to safeguard the fridge against fluctuations in power supply voltage. Do not keep the freezer open for more time. Do not use any chemical for cleaning the refrigerator, as this will result in deterioration of the insulator linings, and there may be a possibility of contamination of foodstuff stored in the fridge. When the refrigerator is in use, keep it at least 30 cm away from the wall. This ensures free flow of air through the condenser plate for its efficient performance.